Hi everybody. In this lesson, we will dig into the possibility of using nanoCAD 3D scan in reverse engineering. To do this, I prepared a part of the machine spare parts, namely a piston with a connecting rod. Let's import it. The scanning was performed in millimeters, and we need to import the object into the program in millimeters. We will leave all other parameters unchanged. At the moment, the point cloud is quite inconvenient to display. Let's recalculate the normals to display the cloud more conveniently, and then change the coordinate system. The recalculation of normals command is used. We will leave the parameter values unchanged and execute the command. Next, in the View Mode panel, set the coloring type to normal with a half-space normal setting. As you can see, our piston has turned into different colors. Now let's change the coordinate system. Let's rotate the coordinate system by 90 degrees around the x-axis. As we can see, our coordinate system is now set correctly. Let's save this coordinate system so that we can always return to it. After that, let's cut the connecting rod, since we will only create a piston. Let's cancel the clipping, as I didn't do it quite correctly. Perform another clipping. After clipping the point cloud, use the Create from View command. Next, it is important to create sections that will most clearly characterize our piston. Let's use the Recognition Parameters command to set the parameters for object vectorization. We will indicate the recognition result as polylines. Let's set the position of the section at the origin and specify a width of about 5 millimeters. Next, moving the slider's max edge and accuracy, we will select the optimal parameters, since later these lines will be the fundamental lines when building the model. Save the parameters and go to the next step. At the moment, the most important thing is to create layered sections. Set the view to the position in which the sections will be drawn and use the Layer by Layer Vectorization command. Let's change the coordinate system parameter to View and leave the other parameters unchanged. As you can see, we have created 10 consecutive sections. The most significant is the middle one. So let's disable all layers except the one in the middle. At the moment, it is important for us to create a contour that will circumscribe our piston and will be a general-purpose primitive without additional details. So we will now begin to create our sketch. Turn on 3D History. Let's draw a general outline based on the created polylines. I suggest hiding the point cloud for convenience. Now you can draw it not very carefully, and then we will clip the contours to get a contour for rotation. Now let's trim the contours and remove the extra contours. Now let's use the 3D Revolve command to build the body. We will return the point cloud display. Now we need to make a hole on the side of the piston. To do this, you can also create sections that will help you understand the most specific points when creating a hole. You can set transparency for a solid. It will be much more convenient to work this way. Let's switch to the right view and create the sections. As you can see, the sections have been built, which we will use to navigate when creating the hole. We will disable some of them so that they do not interfere with us. Let's create a new sketch and draw the lines that will now show the outline, and then clip and mirror them. We will perform contour extrusion, taking into account that this will be integrated into our existing body and the cutting function will be used. Now you need to create grooves for oil removing and piston rings. To do this, we will include the middle section that we created in the first case. We will create only the uppermost groove, since they are all the same, and it will be possible to use the array function to create the other two. Let's add a new sketch to the drawing. We will also draw it in a general way, and then we will cut and impose the necessary dependencies. Then, using the 3D sweep command, we will cut out the contour. Then create the two remaining grooves in the piston using the 3D rectangular array command. Let's choose what we're going to cut, specify the direction, specify the number of elements to create, and measure the distance between the top and bottom edges of the groove. That's it, you're done. Now there's one more important thing left: create two elements where the piston pin will be inserted and the connecting rod will be fixed. Let's create 4 more sections. Choose top view to build the contour of this part of the piston. Let's leave only the layer that most clearly describes the geometry we need enabled. Then add a new sketch associatively to the upper contour of the piston. Now you can create a sketch in a similar way and then clip it. We will extrude this contour by measuring the distance from the top to the bottom edge. Let's add a hole in this element using the previously constructed section. Let's mirror this element. It remains to add chamfers and fillets. Let's do this. Some fillets are easier to select using the selection method, as they can be easily edited using the 3D history panel. After building the model, it is important to perform validation to make sure that the model actually matches. Let's select the point cloud and the built object, and then use the comparison command. Next, we will specify a radius of 1 millimeter and make a comparison. The dot cloud itself has been repainted in colors that show the deviations that can be seen on the right. The black dots of the cloud have an infinite deviation and do not participate in the comparison. In general, you can see that our point cloud is almost all green, which indicates the correctness of the constructed model. When analyzing, it is also important to understand that often all deviations tend to a normal distribution. If this is not the case in your case, then the model is completely incorrect. This concludes our lesson on reverse engineering in the 3DScan application. Thanks for your attention. See you in the next lessons.